Hello legends. In this video, I'm going to be going over the GPT 4.1 prompting guide that was created by OpenAI. This guide goes over the key differences between the 4.1 model and its predecessors, like the 4.0 and previous models, and it explains that because of the differences in how it was built, there's actually differences in how you should actually prompt it as well. So this article is fantastic. Lots of really good information in here, but it is very long, very text heavy, and very dense. So in this video, to show you a highlight reel of what we're going to be learning and seeing is I've actually taken that article and I've highlighted interesting stuff, key takeaways, key learnings. I've annotated it as well. So we're going to be going through probably the most interesting stuff, the stuff that I think you should actually know. Although I do recommend just go and read the article yourself after this video as well. And I've also got an Excalidraw workbook where I've got things like this, which is like a visual breakdown of some of the concepts that are discussed in the article. If I just zoom out, we've got a bunch of different stuff here that we're going to be covering. So I think I'm a very visual person, so this is for me much easier to understand than reading a couple of paragraphs of text. So I think it might be good for some people to just see visually some of the differences in the prompting just to learn. But then I also break down, I kind of pull in extracts from the article and I just break them down into like how you should use it, what it means. I try and focus on little nuggets of information. I also just look at, I use NaN a lot for my videos, and if you're watching my channel, you might use NaN or you might do custom coding. I'm trying to explain to you a little bit more of the technical information about how you should set up your prompting. And then at the very end of the video, we dig into what's the actual recommended output structure for a prompt, how it should look. This is recommended in the article. And then I've got a breakdown over here of each section, what it means and some examples to really just help you build your prompts. In addition to that, we've got a couple of different sources that we're going to be looking at. So we're looking at over here in the OpenAI playground, we're looking at this little feature which helps you generate prompts for your AI models, which is pretty cool. It's an OpenAI feature. I'm also going to be going through just briefly, some documentation for OpenAI. So one cool thing is, for example, in this explanation here, if I just zoomed out, you would see, but this is using XML tags within a context of a prompt. So this is also referenced in the article, the 4.1 prompting article. The XML tags actually improve the output efficiency or the output accuracy of the model when you're using XML tags. So I'm just going to show you this little cool feature just to start broadening your understanding, or just trying to make you a bit better with prompting, to be honest. I then also go into very quickly Anthropic's public resource of how to learn prompt engineering it's made for the Claude models, for Anthropic models, but really this is applicable for quite a few different models that you use. They also use XML tags. So XML tags, I'm going to highlight in this video as something pretty important that I think you should learn to use, and I've been using them as well more and more. But yeah, I just really want to kind of go over this article, show you what I think is most important, and just try and bring you up with me. At this stage, if you're watching this video, I'd appreciate if you could drop a like onto the video. That would help boost the engagement. It would actually help push this video out to more people. It would help me grow my channel and just try and, help me reach more people, which would be pretty cool. But at any stage, if whatever I say, you think you have more, if you do have more information about this, if I say anything that's wrong, drop a comment below as well. I do want to learn, I do want to get better. So I'd appreciate, I'm happy to learn from anyone, but I don't really care. So if you do know information, I'm pretty sure everyone watching this would want to know more information about this too. So where I want to start is actually by speaking about why I think 4.1 is important for us to pay attention to. So the 4.1 model, from my understanding in this article, is firstly, yes, it's built differently to the 4.0 model. And specifically, what we're looking at here is that the 4.1 model is better at following instructions. So what that leads to, the connection that I'm making is, okay, the 4.1 model is getting closer and closer to basically being very good at agentic workflows. So we've all been building agentic workflows now as it stands. And an agentic workflow, if you watch my channel or if you just build custom coded stuff, is the concept of an AI agent. You have an AI agent that has a brain, like a 4.1 model, has a set of instructions, like a system message, and it can do tool calling. So in the context of a workflow, like an agentic workflow is using some kind of LLM system like this. So we've all been doing that. But what I think is happening with the 4.1 model from OpenAI, with the 3.7 model from Anthropic, with the 2.5 model from Google, Gemini, all these models are kind of stepping towards more and more of this next level model. And to kind of support what I'm saying here, to kind of give you my own understanding of how I'm trying to deliver this message, I want to jump across to a YC article. So YC, Y Combinator, is actually a tech firm which invests in AI startups. Or actually, it doesn't just invest in AI startups, sorry, it just invests in tech companies. And it has a very high success rate of picking out really popular, really good, I'm probably just describing this wrong, but like tech businesses. So over here, you can see that you have Human Loop, which is building reliable AI products. And this is, an AI product. Then we have TrueWind, which is building digital staff. This is another one, Shepherd, which is AI-enabled self-study. So I think this is specifically looking at AI startups, but really Y Combinator, so YC, actually has this so-called wish list of businesses that they're going to be investing in 2025. And they're saying that they're actually putting all their chips in a basket of AI, kind of like AI agents, AI employees that they can sell to companies. So you have full stack disruption, so like AI software employees, AI agents and personal assistants, AI employees for healthcare, voice AI, and a bunch of different, like you could just see a bunch of different AI staff members. So when we're coming back into here, if we know that one of the biggest firms that actually invests and is trying to pick out the best AI companies, if they're looking at AI agents, well, OpenAI's best interest is to start building models that will bring us close to the space of a kind of these autonomous systems where an AI agent has to actually replicate what a human does. Because this, at the end of the day, an AI agent is a replacement for a human. A human has a brain. If you work somewhere, you've got a role and responsibilities. You've got a set of metrics that you actually have to, like KPIs against your own performance. So an AI agent, this system itself, is trying to replace what a human does. And replacing human thought, human ability to do complex reasoning, complex problem solving is not very easy. That's why I think this 4.1 model, it's very interesting. I don't think this is the be all end all model, but I think in general, the 4.1 is like, now we're taking steps more and more towards this specific area. And this specific area, it's all trending towards AI staff members, or like, I think right now it might be AI staff, then it'll be AI team, and then it'll be AI businesses, but to that space. So over here, we've got this reference to a benchmark, which is SWE. And apparently the 4.1 model solves 55% of problems. So the SWE benchmark is actually a benchmark that evaluates the AI model's ability to solve real-world software issues. So in the context of software issues, it's a very difficult problem to solve. But if you're building something like AI staff members, going back to this here, like AI assistants, AI voice assistants to like manage your email inbox, the problems that these guys have to solve, or these AI systems have to solve, is not as complex as software problems. So what I'm saying is that if the 4.1 is really good at solving really complex software problems, it's going to be very good at solving these like day-to-day problems as well. An email agent, a healthcare agent, a customer support agent, an email assistant, whatever else. So that's why I think it's important for us to pay attention to the 4.1 model. And yeah, it's important for us in general to just understand that the 4.1 is a little bit different to the 4.0. So even if you have even if you've got an existing automation or workflow that uses the 4.0 model, just replacing the tag that says which model do you want to use, and instead of just putting it to 4.1 and kind of going away with it, to really unlock the power of the 4.1 model, you have to prompt it in a slightly different way. So yeah, now we're going to get into the actual crux of the article. I hope that now we're on the same page about, or at least you can understand why I think the 4.1 is pretty interesting and pretty important to pay attention to. But yes, we have over here, this actually underlines how good the model is at following instructions. So if the model behavior is different from what you expect, a single, firmly and unequivocally clarifying sentence will most likely steer the model into the right behavior. So let's say you have a prompt and it has 10 steps, a bunch of different information about how to actually build, how to actually take your problem to a solution. So if we go into something like this, if you have a prompt over here, and then on the left-hand side, you got a problem, and you got to take the problem to a solution via the prompt. If this is not really giving you desired output, what the 4.1 can do is it just says a simple sentence can actually, it's that good at following instructions. A simple sentence can just shoot you into the right direction. You don't have to restructure your entire prompt, which sometimes you would have to do, previously with the 4.0 model. You might have to fully change how the prompt is built, fully change your initial steps, how it actually tries to solve the problem. A single sentence can, and so I don't really have an example for this, so it's kind of hard to understand just how useful this is, but that's the point that it underlines, is it's very good at following instructions. So I'm just going to jump across to 1.1 and 1.2 to speak a bit more about this. which should push the point across more. Okay, so optimal context size. So we observe a very good performance on needle in the haystack evaluations up to our full 1 million token context. So back in Excalidraw, I've got a kind of a highlight section here of all the cool things about the 4.1 model. So over here, we have the 4.1 model has a 1 million token context window. For perspective, this is like, there's a book called Crime and Punishment by Fyodor Dostoevsky, which is like 500 pages. I don't know if you've heard of it, but imagine a book 500 pages. You can fit 3 of those books into the context, into the 1 million token context. So it's actually just over 3 books, which means that you have 1,500 pages of context within this 4.1 model when you're sending one of the messages in. And the needle in the haystack, this means that, like imagine that you just want to find 5 tokens within a sea of 1 million tokens. It's very good at finding those 5 tokens. So let's say I give you, as a human, 1,500 pages, which might have, I don't know, tens of thousands of sentences. And I'm like, hey, find this one sentence amidst these 1,500 pages of tens of thousands of sentences. And imagine you could do that within a few seconds. Okay, here is that specific sentence that you're looking for. So that is truly impressive. And this actually feeds into later on, we're going to be speaking about how to build your prompt now, knowing that, which is going to be basically, we'll be looking at different features of how to set up your prompt to be able to work with these massive contexts. So that was 1.1 and 1.2. This is the next thing over here. Okay, so note that if your existing prompts include these techniques, it could use 4. Okay, so this is saying over here is, unlike previous models where you would have to use like caps locks or do these like really sneaky things like bribe it, like I'll pay you $5 if you really think deeply and solve this, which are things that people were actually doing with previous models. You don't have to do it with this model. It's so good at following instructions that if you simply take the 4.1 model and put it into a prompt that was for a previous model that was not really good at following instructions, you might actually screw the system up because it could pay attention way too strictly to that. So that's a very interesting point as well. So literally it's saying here that, okay, for this needle in the haystack situation, from the 1 million tokens, we can actually understand and observe every single like individual section of tokens as independent contributions to the prompt, which is massive. And then it's also saying, be careful not to over prompt it using these old school techniques because they will make your system fail. So yeah, I think that's really, really cool. Now going back up to the top, we have the next section is system prompt reminders. So because we have that massive context, that 1 million tokens, it just makes sense that you need to be tapping it on a shoulder certain times to basically say, oh man, I've given you 1 million tokens of context. Here's what I need done on this 1 million tokens of context, and to try and basically keep it calibrated towards getting you the desired output. So this section here I've actually copied across to Excalidraw. This is saying that there are three techniques, which is persistence, tool calling, and planning, that OpenAI did when they were testing this model. So persistence, tool calling, and planning, that were able to achieve an improvement by close to 20% against that benchmark score that we spoke about before. 20% from 3 simple techniques: persistence, tool calling, and planning. So over in Excalidraw, let's shift across to that section that we want to speak about. So here we have the 3 sections. Now, for this section here, think about it in the context of the 1 million tokens, and 1 million tokens being 1,500 pages. So what we're saying here is that persistence, this ensures that the model understands it is entering a multi-message turn and prevents it from prematurely yielding control back to the user. So that first part is, it kind of goes in line with GPT 4.1 being really good at following instructions. So imagine you have a prompt, very basic prompt, that has a number of steps in order to take the problem across to a resolution. So what these older models would do, if you didn't use caps lock and try and bribe it, would be that it might complete step 1, step 2, step 3, and then kind of trick itself and kind of exit out of the sequence and go into a solved, which would cause you to have a failed result. It wouldn't actually be accurate because you didn't complete step 4 and 5. So in general, 4.1 is so good at following instructions, that article is saying that it's much better now at following every single step that it needs to. But with this persistence thing, that the model understands it is entering a multi-message turn, this is a sample prompt that you can put into your, or a sample like sentence that you can put, instruction you can put into your prompt to help with that persistence, to make sure, hey, we've got multiple steps here. You're an AI agent. Please continue going until the user's query is completely resolved. Before ending your turn and yielding back to the user, only terminate when you are sure that the problem is solved. So that's like pretty straightforward instructions that you would actually insert into this prompt to try and make sure, like, even more that, hey, there's multiple steps here. And this seems easy, step 1, step 2, but this could be first analyze and review this entire problem that you're receiving. Compare it to the context that's provided to you. Step 3, make a tool call and now re-review what you've just read and add the additional context to the previous context that you have. These are very complex steps. So some of these systems can be actually very, very sophisticated. That's what this first persistence one does. So after we look at persistence, we then have tool calling. So tool calling, this is, you probably experienced it already. This is where hallucinating or guessing an answer can come from as well. So this encourages the model to make full use of its tools and reduces the likelihood of hallucinating with the fact that it is good at following instructions. Again, this, whatever is in here in this code block is just reproduced here. If you are not sure about the file content or the code database structure, again, this is because the SWE benchmark for software problems. So you just adjust this to your own use case. If you're not sure about the content of the customer support ticket that you receive, in order to answer the request, just please use the tools that are provided. So it's actually much better at following tools. And later in this video, I'm going to be going over some like how you have to set up the tools in, for example, NAN to make sure that you're marrying up the tool to the actual prompt. So yes, we have here to the user's request, use your tools to read the files and gather the relevant information. Do not guess and do not make up an answer. So that's another thing that you would add into your prompt to make sure that you're going to be getting the most successful output. So like a resolution and not like a failed resolution. And the final thing is planning. So planning is very interesting. I've just taken again out from this code block into here. You must plan extensively before each function call and reflect extensively on the outcomes of previous function calls. Do not do this entire process by making function calls only, as this can impair your ability to solve the problem and think insightfully. So once again, if you just look at like each step here, what it's saying is, imagine this is all just function calls, for example, or it could be this is a function call, that's a function call, that's a function call. It's saying that after you do the function call, before and after, just make sure that you're doing this for a reason. You're not just doing it to follow the steps. So actually think a little bit more, kind of turning the 4.1 into a bit of a reasoning model, which we always also discuss later. But before you do the function call, consider, is this the right thing to do? After you do it, review it, and then analyze now the entire context again. Like just re-review that. Here's the returned information. What does it mean? Do we actually go to step 2 or do we go to step 2B? And that's what it's speaking about here when you're doing planning. And that planning is not just at the very, very start of the actual like prompt. It's like planning, reviewing, optimizing during the actual execution as it tries to take the problem to the solution. So all I've done here is I've looked at the comparison between just a bare bones prompt, and I've tried to ingest those 3 different sections into here to show you how they would sit. So you have over here the core prompt with the instructions, plan and reflect. So you might put that sentence that we had over here, this plan and reflect sentence that was here, into this top section for planning and reflecting. Tool calling, you might put this tool calling, maybe you wouldn't put at the bottom here, but this is just to show you, you'd put these two, planning and reflecting, tool calling, into this top section of a prompt. And now that you actually have 1 million token context, this context is actually where you would ingest things like the actual problem itself. You might ingest different context of the problem. So maybe you have another API call that ingests all the historical customer support tickets from this specific customer. So all of your different data sources, you can insert it into this prompt if you wanted to, in addition to doing tool calling, which would then seep out into different data sources as well. But that's what you're doing here. You're literally building the start of the prompt to have some of these techniques built in. Then you have the actual context. And in the article later, we also read about a final reminder, a final set of instructions after the very context. And actually the model, I think the 4.1 and other models, they'll actually listen kind of more to the final instructions at the very, very end when they're generating their output. In general, models, the longer the context, they pay really good attention to stuff at the start, really good attention to stuff at the bottom over here, and sometimes in the middle, this stuff, it gets kind of not lost in translation, but it's less likely to follow the instructions here. So in this space between the start and the end, this is where the 4.1 model shines, which is why you can put a very large context. And like we spoke about, it has that needle in the haystack thing, which you can literally pull out 5 tokens from the sea of 1 million tokens, which is truly impressive. But that's how you would start building your prompts. So this is like learning one. This is how you would be structuring your prompts now. You can put a lot of context into here. You must have a final reminder at the end. And you're probably already doing some of this stuff now. But this is like, the 4.1 is really good at following instructions. And all we're doing here is giving it more instructions and just more structure and stability into how it's completing its process. Now going back to our guide. So we've spoken about these system prompt reminders. Once again, 20%. This is literally this, and this. An extra 1 or 2 sentences throughout your prompt will give you a 20% better hit rate for your resolution over here. So that's such a simple improvement that can actually get you a lot of benefit. Scrolling down now, okay, to tool calls. This is another interesting one. So developers should should name tools clearly to indicate their purpose, and also add clear detailed descriptions to the description field of the tool. So this is where we had this NAN visual over here. So at a high level, if you're building an AI agent in NAN, the breakdown is you have the AI agent, you have the system prompt, you've got tools that are attached to it, and you have the 4.1 model, for example, or any other model that you're using. But for this context, 4.1. So within this tool, you have the tool name and tool description. And then I've just literally opened up this tool that we had here into this picture. So you can see tool name and tool description. This is super important because when you're adding new tools to NAN, and I'm gonna show you the code version as well from the article. When you're adding new tools, don't just leave the actual name default, whatever it is, because the name that you're using here, you must use in the system instructions. That's what this next section is saying. In your system instructions, you must actually use the same name as what you have here that have higher accuracy of actually using the correct tool in the execution. And then tool description, also important. So what you're actually looking at here is a visual interface, but when it's applied at a code level, like NAN is just like drag and drop for code. It makes it easy for you. You don't have to code, but in the backend it is code. So this structure is actually built out like how OpenAI is expecting it. So changing this tool name and tool description does feed into the higher success of the 4.1 model. So we've just looked at how to do it with NAN. And if I go back to this guide here, actually this one will be better. Where is our tool section? Chain of thought, long context, and then tools. Okay, so it's this section here, tool calls. And how it's done here is that you have your system prompt, so all this information for system prompt, but then that section that we saw for the HTTP call, that's this over here. So their tool name, Python bash patch tool, and then the description, which in this case, this is a very complicated description, so they've actually got a standalone section, but it's this entire bit here, this entire thing here. So it's a little bit different to NAN because when you're doing custom code, you can actually put proper instructions that have much more detail and action steps that you can take. Within NAN, you're kind of like, you have guardrails up, so it's a slightly more restricted environment. But look at the description that they're using over here. Exactly what the tool is, what it does, how to use it, all the different bits and pieces. So then when you're calling this tool, you can have really high success rate at actually, again, it's all about getting the right answer. So it's all about that SWE benchmark that we referenced before. But for our agents that we're building, these AI systems or these AI agents, like what Y Combinator is looking to really invest in, all this stuff, these guys are doing that. They're definitely going into the prompts, making sure the prompt is accurate for the model. They're doing lots of testing, which is what we're going to be speaking about later in this video as well. Lots of testing. They're making sure that tool calls are using the appropriate configuration, the appropriate naming conventions, the appropriate description. So if you want to get into that space, you have to be doing this stuff. So we have a tool call over here. If your tool call is particularly complicated, you can create an example section in your system prompt, which is what we were looking at before. This is the system prompt. So within here, you would actually have the example section of how to execute that tool. I don't think for NAN workflows, we would necessarily need to use that. But for custom coded workflows, you would have to use something like that rather than adding them to the description field. And that description field, like what we saw here, is if this is a pretty complex tool, which it really won't be in NAN, you don't put the description, you don't really put all the instructions into here. You would add them into the system prompt. So that's how you actually do that. And that's what we had in this coding example here. We had that system prompt, or we had the tool description here as its own standalone prompt, or its own standalone description. So to finish off this tools section, we actually have, like it says over here, like, remember you can use the generate anything in the prompt playground, and it's a good starting point for defining your new tool definitions. So going to the playground, that's what we have over here. So this is literally just copied from that. I've clicked that hyperlink and we have this prompt section, and you can press this button to help you generate some of these prompts. Although I would actually just use the techniques from the article from this video as well to start just getting better at creating the prompts yourself instead of constantly relying on AI, because everyone's relying on the AI. So what sets you apart? So yeah, just learn how to do it. And this tool section here, you can create different tools. You can kind of play in this playground. It's got sample definitions. This is more if you're going to be doing custom coded stuff. Yes, for sure, but it's a resource that we're being linked to. Otherwise, if you're using nanmake.com, just make sure this stuff is actually filled out. The tool name, tool description, reference the tool name in here, put some more information about the tool if you need to into the system prompt as well. The more information, the more context, the better. All right, so prompt-induced planning and chain of thought. So like we already spoke about, developers can optionally prompt agents built with 4.1 to plan and reflect between tool calls. So that is specifically this thing here. This planning and reflection between tool calls, which again, these three components all added to 20%. And this specifically added to 4% in like success rate for the desired output. Instead of silently calling tools in unbroken sequence, 4.1 is not a reasoning model. So that's another important thing. The actual, like what we're doing here by saying planning and thinking is, let's imagine just for argument's sake, these are all different tool calls, 1, 2, 3, 4, 5. We're saying that between each tool call, at the start of the tool call, stop, think, and reflect. Okay, what are we doing here? Okay, cool, make the tool call. After the tool call, stop, think, and reflect. Okay, what have we done? What's the new context? How does everything look now? Okay, tool call 2. All right, what's the intention of this tool call? Okay, what's the context that we currently have? We've just completed one tool call, got this additional context. Like, it's literally stopping at every single stage between tool calls, and it's making the model, it's kind of turning it, it's not turning it into a reasoning model, but it's giving it the ability to do this reasoning. And that itself is important because in general, we have here, the 4.1 is not a reasoning model. It's not a reasoning model, which means it doesn't like, it's not an O3. It's not an O1 model, which will take time to spend tokens to actually think about problems. But the 4.1, what it is good at is it's good at following instructions. So what you're trying to do here is fuse those two elements together. A model that's really good at following instructions and a model that's really good at stopping, thinking, and reflecting, because thinking and reflection will give you a better result. Actually, like, planning in general, like success favors the prepared. Planning in general gets you a better result instead of just kind of blindly following the steps and not really paying attention to what you're doing. So the 4.1, this is like, that's what they're saying here. It's not a reasoning model, but you are trying to make it kind of, resemble or, do things that a reasoning model would do because it gives you a higher accuracy. So that's that 4% that we're speaking about here. Now, if I zoom out, there is actually a technique that OpenAI speaks about for how to get that chain of thought prompting into your actual prompt. So the actual bit that we would be speaking about is this planning, this thinking and reflecting. So this instruction set here, if we go to this part here, that's what it's saying. How do you actually optimize this? How you can actually build this out? So this bit here from this code block and this from this code block, I've copied across to Excalidraw. And the contrast here is actually disgusting. I'm sorry, guys. But so what it's saying is, first, we want you to start small. So we recommend starting with the very basic chain of thought instruction at the end of your prompt. Okay, so that's what it's saying. The very end of the prompt is, jumping around a lot, sorry guys, is this bit here, the final reminder. After all the context, the final reminder. So it's like, okay, here's the instructions. Here's your context. Now slow down, breathe, stop and reflect after each step. Make sure you're on course, you're doing the right thing. That's what it's saying here. And it's giving you the instructions on how to actually build that sentence accurately. So it's basically saying first, in Excalidraw, we have the text copied out. Think carefully, step by step, about what documents are needed to answer the query. Then print out the title and ID of each document, then format the ID into a list. So this is what you would put at the very end of the prompt. This is obviously specific to like a certain use case, but let's say you're doing customer support. You might first say, because customer support, you might get multiple different types of queries. General questions, warranty concerns, and order tracking. Each of these would have a separate set of steps that you need to do to get the answer. Like you wouldn't just ping the RAG database if you need to do a order tracking request. You wouldn't do that. So maybe you would start with something simple that says, first think carefully, step by step, or think carefully about what request you're receiving and categorize it into one of the three. General questions, warranty, or order tracking. And that would be your initial first step. And then you might say, print out what the ticket category is, like what the contact reason is. And then it's saying that when you do this, look at the desired output and then iterate step by step. Then you might, get to something that's a bit more complex, but you would literally break it down bit by bit until you have an entire set of steps as your reasoning strategy, as your planning and thinking strategy. So I've got that copied across in Excalidraw. Actually, before we get to that bit, we can get there. It is this reasoning strategy here. So break down and analyze the query until you're confident what it might be asking. Consider the provided context to help any ambiguous or confusing information. Context analysis. Again, this is all just like spend tokens thinking. Don't do tool calls. Don't do actual work yet. Like generate an action plan for how you're going to be solving this. And this is all going at the very, very end of the prompt into that final section. So carefully select and analyze the large set of potentially relevant documents. So you might actually have the documents within the context, or it might be a tool call, and summarize which documents are most relevant, including all documents with a relevance rating of medium or higher. And then, for our case, for the customer support, it might be like, analyze what the customer is asking about. Is it a general question? Is it a warranty? Is it a order tracking request? based on that information, just understand, do you have all the information you need to actually successfully answer the ticket? If it's an order tracking request, do you have the customer's name or order number that's going to be needed? Okay, if you do, then generate a small action plan for how you're going to approach this problem. Here's the tool calls that you have available to you, generate your plan and then execute. So that's the kind of like how you would approach this. Well, this is a reasoning strategy, but this is essentially like the planning and thinking between tool calls, or planning and thinking for how to solve the problem in general. So this other cool section here, it speaks about where errors tend to come from. And just like we spoke about at the very start of this article, we spoke about the GPT 4.1 model is very good at following instructions. So typically one sentence can actually get it back on track. So if you've created a prompt, you don't have to worry about like you have to rewrite the entire prompt. You'll be able to get away with actually just making minute changes. So this is saying that generally speaking, errors tend to occur from misunderstanding of user intent. So if you haven't completely, if you haven't accurately articulated your problem and what you need done to it, so user intent. This is let's say this is the customer support ticket. So the actual model is not understanding, for the context of customer support agent, it's not understanding the user's intent. It's what they're messaging about. Maybe their message is, hi, I need help. So of course the model is going to fail because it's like, well, what do you need help about? We can't actually solve it. So in that case, you might have a fallback option that says, if the user doesn't give enough information, ask for more information. Insufficient context gathering or analysis. So maybe it's not looking at all the context, like we haven't given it the appropriate instructions to say, here's the different data sources that you can actually tap into. So tap into these to figure out what your next step is, or to figure out how to solve this problem. And then insufficient or incorrect step-by-step thinking. So again, this is all about prompting. It can all be fixed by prompting, just telling the system to work a little bit slower, to figure out the appropriate plan for itself. So essentially, this is an example of how you would solve all of these problems by building out a reasoning strategy like this. And you would tell the model at the very end of the prompt, so the final thing it sees is that reasoning strategy, or that planning and reflecting, or that planning strategy over here. So that's what's going to get you this really high output. Again, it's 20% from all three of these. And that's a major chunk of it as well, just planning. And this is what the guide is basically telling you. It's put that section at the very end of the prompt. So to keep going through this article, we have optimal context size, prompt organization. We spoke about this, recommended workflow. So for this section here, I think what a lot of people would do, and what I would actually used to do, is I would ask ChatGPT to write the prompt for me. So I would just kind of go into a ChatGPT window and I would just, generally speaking, say, write this prompt, which was working for me so far. But what this process is now saying is you cannot, don't just go and create a prompt using ChatGPT, actually think about the structure of the prompt. So now that we have Excalidraw, we can kind of see how the format of the prompt should be. I don't think ChatGPT is going to be able to natively understand how the 4.1 model should be prompted, unless of course you just take this entire article, upload it into the context of a ChatGPT project, for example, and say, here's my problem, here's a prompt that I want to create, follow the rule set from this article. So that's what you could do for sure. But this is saying, don't just go use a ChatGPT, actually start building your process like this. So what it's saying is start with a high level bullet point instructions. So when you're first building your prompt, what you just want to do is keep it very simple. Don't put any of the other techniques into here. Don't use any of the planning. Don't use any of the, mention the tool calling, but just keep it very simple and keep it like 5 bullet points. Really kind of like what we're doing here with this chain of thought. It's the same. It's literally, this is a really good way to solve problems. Start small, just give it 1 or 2 instructions, see what the output is, and then keep iterating. This is actually how I build my automations. My workflow for building automations is I don't try build the entire thing. I build one section, I run it, I get the result, I see what data I have, I build section 2. And that sometimes is node by node. It's literally so slow, but the accuracy is through the roof because I don't have 20 nodes and I have to figure out where it's what's screwed up. I go node by node and I kind of build it out. So building out your prompt step by step is also very interesting, very good idea. You just do 3 or 4 steps, run it, see what the output is, and then iterate. So you don't actually have to try and one-shot the prompt. So back in these instructions, start with high-level bullet points, test and review, run it a couple times, see what feedback or what information you get, see what's missing, add section by section. So this is we're going to be speaking about what sections you actually need for building out your prompt in general, which is this stuff here, prompt structure, role and objective, instructions, reasoning steps, example, final instructions. Don't build out everything at once because you're not going to know what's actually producing the good result or what's actually pulling you away from a good result. So you just build it out step by step. So you probably start with instructions first. You build out the initial instructions. Once you have a really good, a relatively good output, but you just need some tweaking, then you might add some reasoning steps. Then you might add some examples. Then you might start giving it some character and say, this is your role and objective. So like all these different parts are all subcomponents of getting to your solution. So that's what this is saying over here is start high level bullet points, so like the instruction section, test and iterate, add section by section, KISS, so keep it simple, stupid. Use examples of desired output. No, don't use caps and don't bribe. So we already spoke about this section before. We don't need to oversell how accurately, like focus on this section the most. We don't need to do that anymore because we know that needle in a haystack, it's going to be able to pull out 5 tokens from 1 million tokens really easily. And if this is the second note, if you are updating the 4.1 in different workflows, so if you're actually using an AI agent already in N8N, for example, and you change your model from 4.0 to 4.1, you must change the system prompt. Like just take the system prompt, put it into ChatGPT if you want to like do it the easy way, and just ask it to help you revise it based on the instructions that you have over here. Like that's if you really want like to kind of like just take an easy way out. But as a fun challenge, you can just start building the prompt from scratch. You have the framework here. Note, if you are updating to 4.1 in existing workflows, you must edit the prompt, and that's going to give you more accuracy. That's the Ferrari analogy. If you put in the 4.1, this is access to a Ferrari. If you do not modify the prompt to be suitable for the 4.1, you're stuck in first gear. You're just like smashing first gear the whole time. But gear 2 would 3x your speed. So just getting one unlock level would actually 3x your output. And you've got six extra levels. You've got 6 gears in a Ferrari, for example. So do not limit yourself by not putting an appropriate prompt. And from this article so far, what we see is it's very easy to build a prompt. We've got the framework here, but even before the framework, just build it section by section. We've got some very visual, basic understanding here of what's important. 20% of the overall 55% accuracy is from these 3 sections. So if you want really accurate prompt, have these 3 sections in this specific order. And then you're going to get, halfway of the way to your results. So that's what we spoke about here. Now, the final thing I want to speak about is actually delimiters. So a delimiter is just like a different tag that you use within your prompts. So what you're probably already used to is using Markdown. And Markdown, if I go to my delimiter section, so it's the same thing here. Markdown is like using hashtag to say this is a H1, this is the most important. Then H2 is like second most important. So you're actually giving the model an understanding of what's important, what's less important, like what to focus on when it's going through the actual the prompt itself to understand what should I put more attention to. And then you have like asterisks, so like this thing. And this is all just varying level of importance, which you could use to denote sections, you could use to denote subsections, or important steps. So Markdown everyone is using. XML, it's actually recommended to use XML as well. And XML is what I spoke about before. So let's say, for example, within your context, within the actual context of your system prompt, you're putting a bunch of information like the problem, some other, historical tickets, a bunch of different context. Those dynamic variables that will change customer to customer, you can insert them using these XML tags. So XML tags, here's an example. What this is telling the model is essentially, this is the start of the user query. And with this / this is the end of the user query. Everything in between these 2 tags is exactly what you must process or understand. This is what you must process. It doesn't get it confused with like, in a very long context, the model can figure out, it can locate those things that it needs to locate. But in order for it to kind of distinguish between different bits of information where it stops and starts, you need to use XML tags. So the interesting thing is here, they speak about, there's 3 types of delimiters that you can use. Markdown, XML, what we just spoke about, and also XML is an Anthropic's prompt engineering like course thing, where it constantly says to use like these XML tags, constantly everywhere XML tags. It's like literally every single instruction. If you put dynamic information in there, you must use XML tags, or you don't have to use them, but like you're gonna have higher accuracy. This is actually a really cool resource. Yeah, if you want to see a video of me going through this from start to finish, just comment below that you want to see that. But what the interesting thing is, sorry for that little jolting there, but what the interesting thing is that it's here we have, okay, XML performed well in the long context. So when you're looking at using 1 million tokens, for example, the longest possible context, using XML tags to denote different parts of the actual prompt. So here, doc ID, whatever, you have fox, the quick brown fox jumps over the lazy dog. So this is start of the actual XML tag, end of the XML tag. The cool thing is you can actually put metadata into the actual tag as well, which is like 10 out of 10 next level. Super long context. Not only are you going to be able to do distinguish between the user query, but the metadata is what gives the prompt even more accuracy in understanding how it should use this specific bit of information. So this is absolutely wild, this specific technique. I might even do a video on XML metadata technique for prompting as a standalone video. But it said that, yeah, XML performed well, but JSON performed particularly poorly. So using JSON within your prompts is not so good. Isn't that interesting? A lot of my prompts, I would actually use JSON within the actual prompt itself. Like, where are we? Where are we looking at here? So like whenever I was doing this, like sometimes I would use JSON to denote, here are your categories that you can choose between. I put like a JSON information. No, don't use JSON. It's not so good, especially with long context. You want to use XML tags. So yeah, that's interesting. That's the final bit we're going to be discussing, or the final bit of this video anyway, is just to end it on delimiters. But like, it's like little bits and pieces like this that will probably add 5-10 points to the outcome of whatever you're creating. So yeah, actually, there's actually one more section. So for Excalidraw here, the final takeaway is, this is the ideal prompting structure. So in the actual prompting instructions here, we have instructions to follow, customer service, general advice. Okay. So this is the actual prompting structure of what you should follow, how you should build it out. You don't need to have every single one of these sections, but this is how it should be built out. Again, context here, and then final instructions for the prompt to think step by step, which is what we discussed already in this section here. The final instructions is that planning stuff that we were looking at when we were doing, I know I'm jumping around a lot, but that chain of thought at the very, very end, which its overall contribution was 20% amongst these three different features, or these three different things that you could do. So for here, the prompt structure, role and objective, instructions, subcategories, and more detailed instructions. It's using Markdown over here. It's using the actual same technique of using the context and then the final instructions, which is a 20% against the SWE benchmark. And then also you would use XML tags. So these, like, you can slowly start to see all the stuff that it mentioned in the article, like all the different, like, yes, Markdown, yes, the structure of the prompt, yes, the including of instructions here. It's all purposeful to get you as close as possible to the desired output. There's a science to this. It's not just an art. So yeah, here's a breakdown. Role and objective, define what the role is, like what it is and what it's trying to do. You're a helpful research assistant. Your goal is to extract clear summaries and highlight key technical points. Instructions is high-level guidance. Be specific on what to do, what to avoid, include tone, formatting, and restrictions. So always respond concisely and professionally. Avoid speculation. Just say, I don't have the information if you're not sure. And it's much better at following that instruction as well. Format your answer using bullet points, sub-instructions. This is another interesting one because I've actually done some reading on this, and sample phrases. This one is, when you put some sample phrases into here, the model will follow the instructions perfectly, which means if you give it like 2 or 3 sample phrases, it would always use them. So in like a live chat environment, it's going to constantly be using those same 3 phrases. If you don't give it like a bit more of leeway and say, you're not going to say don't overuse these phrases, but you have to be specific when you're prompting and say don't just use these phrases. Here is a pool of other phrases that you could use, or use them 1 every 5 sentences to like really mix it up. So sample phrases in a sub-instructions is a new one. I've never done sub-instructions before, so that's really, really cool. Prohibited topics, don't discuss politics or current events. So like these second layer are kind of like, operational instructions. So you're meant to help us like highlight really good information, but when you're doing that, keep it conversational, don't speak about this and that, and kind of, you're putting up guardrails, like stage 2 guardrails for the actual operation, like the personality side of things. Step-by-step reasoning and planning, think through the task step by step before answering, make a plan before taking any action, reflect after each step. That's the stuff that we're speaking about over here, planning and reflecting between each of these steps. And then you had chain of thought. So like, planning and reflecting is a little bit different to chain of thought as well, but both of them work towards making the model more of giving it reasoning, making it a bit more like a reasoning model, but not an actual reasoning model. So you have these step-by-step instructions. Your output format, specify exactly how you want it to look. I typically in here would put even JSON outputs. So I'd say this is the JSON structure that I want. And I would use that when I'm working in NAN or even doing custom code projects, because I specifically would want to then use that data in a separate place somewhere else. So my go-to is just like JSON outputs, but you can see here, respond in this format, summary, key points, and conclusions. Sorry, it's a little bit blurry. And then you pass some examples as well, where these examples are using Markdown in this case. So examples is show GPT what good looks like. So you just give a couple of examples for a customer support query or whatever work you're trying to complete. Final instructions, repeat the key parts at the end to reinforce the model's behavior. So final instructions, once again, is just that section. And I keep coming back to here, so you should probably already have this memorized in your head. Final instructions over here. So it's a very simple layout, nothing too crazy. But that's a run through of how you would actually build it out. And then we have bonus tips from the guide. Put key instructions at the top and bottom. For longer prompts, the stuff at the very bottom is going to be retained and followed more closely. Use markdown headers and XML to structure the import, to put different importance to different sections, to also introduce additional context that is dynamic, break things into lists or bullet points, and if things break down, try reordering, simplifying, or isolating specific instructions. So because it is so good at following sentence by sentence, you can really just like strip away bit by bit and try and find the source of the problem. All right, guys, thank you very much for watching to the end of the video. If you haven't subbed to my channel, if you haven't liked the video, can you please do that as well? Like I said at the start of the video, that's going to help this video push out to more people. It's going to help me grow my channel. So I'd appreciate if you could help me as well. So thanks very much, guys, and good luck with your prompting.